forget and we move into the next video and it causes us a problem. So oil pressure, we're going to go in here into the wiring, and we need to go and change this. So what we have to do is unselect this. Let's set it as AVI 5, even though I know it's not right. And let's go here into fuel pressure, and let's go into the wiring. Let's set this on AV3. That brings AV3 available. And let's click apply. And let's jump back into oil pressure here. And then let's connect it, reconfigure this to AVI 4. Let's click OK. Let's click apply. And then if we pay attention here, if we go here to do a reboot, notice what's going to happen here. There's fuel pressure right there, oil pressure 0. So that's good. Now it's just a quick way we can test some things. Now this layout that we're working with, this is available in the training course, so you can download this, all these different page layouts that we'll be moving through. That'll definitely speed up your calibration process using the Elite. So you're going to definitely want to do that. So now that we've configured all of the input and output details for the harness, for the vehicle, let's go in through and start off at the top here. And we're going to go through our Ecu Navigator and just go through our core tables and some of the configuration details that we need to get out of the way so that we make sure things are going to work right when we're going into the next couple videos and doing our calibration. These are things that you always want to make sure are right on your Elite before you do your tuning. And a lot of what we talk about here isn't going to be case series specific. It's going to be just overall applied to any application with the Elite, but it's going to be things that you definitely want to take care of. All right, so let's move all the way up here into Lambda. We're going to go into our target Lambda table. This is going to be where we specify what we want our target air fuel to be at based on engine RPM and then based on load input we have coming in here. So right now this is set on manifold pressure. Now because we've set our main fuel table in our fuel here, we've set this on throttle position base. Fuel load, if we just quickly go back here, under engine, under fuel, under the fuel load type, we set it as TPS. We can see here fuel load is going to be TPS. In fact, if I move my throttle around here, we can see where my cursor is at right here. We can find it's moving across that table as my throttle position changes. We can see it's going to be varying. So we want to go in and have our target air fuel table here to be based on throttle position. Now, if you're going to be in a forced induction application, you wouldn't want to do that. You'd want to have it based on manifold pressure. So you'd make sure that your scaling here goes all the way out to the highest map sensor range you're working with. If you're running 30 pounds of boost, 29, 30 pounds of boost would be fine. If you're going to be running 50 pounds of boost, you'd have to rescale this table out here. Now it does take the last column here. So if you were running 50 pounds of boost and you were here on the, let's say 29 column, it will reference this target air fuel as you go up higher in actual boost pressure, but just be aware that it's better just to scale it out so you can be a little bit more specific. Now in this case, we need to do it based on TPS. We actually can shrink this table way down here. So we're going to go up into our table axes setup and we're going to set this up. So under the enable axes, manifold pressure, we can find that's up here. We want to set this on throttle position. Now we could set this on fuel load because we have set it on throttle position. We specified that. So let's just do it on fuel load to keep things continuous between the tables. Now in our variables here, this is going to be what we want to set our throttle position thresholds at, or the load breakpoints in the table. Right now that's based here on our actual manifold pressure. So what we're going to do here, we're going to be changing this to 0% throttle. We're going to do here 1. We're going to do 3% throttle. We'll do, let's say, 5% throttle. We'll do 15% throttle. And then we'll just kind of jump our way up at the table here. 30% throttle, 50% throttle. Let's do 70. Let's go 60% throttle here. We'll do here at 45. We'll just move in 15 increments. 75. And then we'll go here 100. Now, we're going to have more data points here that we don't need. So we're going to grab these and just do delete. So we're going to delete all these points up to 100%. So we've rescaled that. So from 0 to approximately 100, we have a bunch of different breakpoints here in our table. Now in our other axes here, we have engine RPM. So it's going to go from 0 to 10,000. Now I don't need to go all the way out to 10,000. Let's go and take away that 10,000 breakpoint. So go from 0 to 8,000. Let's click apply. Let's click OK. Now we can see our table shrunk down a lot more. And what we're going to find here is that we have our TPS. We can see as I move my throttle position across, we can see our cursor is moving here. We're at that 0 RPM point. So it's giving us that position in the table here. What I'm going to do at my lower throttle angles here from 0 to probably about 15%, we're going to be setting this all to 14.7. This should be able to run that 14.7 air fuel. Now we are running ethanol-based fuels. The one thing I'm going to keep in mind with this, with the target air fuel table, and we have our unit scale. If we go up here into tools and we go into options, I do have my unit scale for air fuel here set onto air fuel, gasoline, petrol. If I set it onto Lambda, everything will be displayed in units of Lambda. Now the wideband is actually sending in a 0 to 5 volt signal, and that's going to be scaling it out based on actual Lambda. The Haltech's actually going to take that Lambda signal and convert it into what we're specifying here. So gasoline, petrol, methanol or ethanol. Now I want to display on gasoline, air fuel, petrol, because that's what I'm more familiar with. But if you're tuning in, let's say flex fuel based tuning, going from petrol based to with flex, or if you're tuning in methanol or M5 or any kind of other kind of exotic fuels, you'd probably want to go and tune in Lambda. There's nothing wrong with tuning in Lambda. So 1.0 Lambda is stoichiometric for any kind of fuel, and then this is allowing us to just take that and display it in units that we might be more familiar with. So I'm going to be selecting air fuel, gasoline, petrol. That's why we find our values in here are going to be still in gasoline air fuel, even though we're running ethanol. Because the wideband outputs units of Lambda, then the Haltech here is just doing a conversion into units of gasoline air fuel. It's pretty simple how that works, but I just wanted to specify that. A lot of people are confused with that kind of situation here. If we went...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.